Hello everyone, hope all of you guys are doing well. Today we will try to understand handwriting.py program. So in the program we can see import sys. It lets us access system specific parameters and function, and then we can see import TensorFlow as TF. So what TensorFlow usually does is save a model to a file such that we use the model we learn later using it which already exists, which will reduce the time to train a model manually. So TensorFlow has some dataset built into the library. So in here what we see is MNIST. MNIST is one of the famous dataset which has the dataset of whole bunch of samples of people handwritten digits. This line access the dataset which is built into the library. We can use it to train whole bunch of handwritten digits. If anyone has their own datasets, they can use their image and formatting it to arrays of pixels. And here we will see we prepare the data for training. So we have to do some reshaping, just turning the data into format that we can put into our convolutional neural network. So in this code is used to loading data, and in this line of code it uses the normalist pixel values. So in here we can see is 255. What is 255? Basically what it does is taking all the values and dividing it by 255. Color values range from 0 to 255. So we can divide them by 255 just to put them into 0 to 1 range, which will be easier to train. And here what we can see, this is responsible for encoding labels to ytrain and ytest. And then here we will this is responsible for reshaping data for our neural network. Then here we finally create our neural network, which is from Keras, and method is sequential. In this method we pass input to this sequential network, essentially the list of all the layers we want, these layers. Okay, and then what is a convolutional neural network? In here, in this code, this consists of 32 filters using 3x3 kernel matrices. Here we are gonna learn 32 different 3x3 filters. Then we use ReLU function. So what is ReLU function? It helps prevent exponential growth in computation required to open neural network. This specifies the input shape. Here input shape, and the input shape is 28 by 28 comma 1. So because MNIST organize the data 28 by 28 pixel grid for image, and each of this image has one channel value or single color value. This one is responsible for that. And then what we can see is max pooling layer. Max pooling layer is built into the TensorFlow. This layer is using pool size of 2 by 2, meaning we are gonna look 2 by 2 region inside of image and extract the maximum value. Essentially it will reduce the size of input. And here what we can see is flatten units. This line of code will flatten all the units to single layer. We can pass it to the neural network here, and then we will add hidden layers. Here we add hidden layers to neural network with 128 units, and the activation function is ReLU. And here what we can see is dropout function. Dropout function is mainly used to prevent overfitting. So we add the dropout, and here 0.5 means randomly drop out half of the nodes from hidden layer. And here what we can see is output layer. Output layer has 10 units, one for each category to classify digits such as 0 to 9, and the activation function is softmax. Also, so what is softmax? Softmax function is going to take the output and turn it into probability distribution. Then here we will compile our model and fit it into our training data here. So optimizer is Adam, loss is categorical cross entropy, and matrix is accuracy. And here what we can see is this is responsible for fitting our data to the fitting our model to training data. Then we evaluate how well the neural network performs from this code. And then finally we add our arguments to our program. Then we save our model to the file. Let's run our program now. It will take some time. Let's wait. It will take some time, and I will be back when the execution completes. Okay. Finally, we see our program has executed perfectly. Here, what we can see, we have worked with 1875 samples, and we have iterated or epoch 10 times. Here we can see accuracy. Every time accuracy gets higher. And here what we can see is testing it. We have tested it, and we have tested with 313 samples, and the accuracy is almost 99%, or we can see is 98%, and the loss is 0.3%. And then if we see here to the file, we are seeing is there's a file named saved model. We can use it later for similar execution or similar program to train neural networks. That's it for today. Thank you.